Hello, welcome to the Laptop YouTube channel for machine learning. In this tutorial, we will discuss the linear discriminant analysis, which is also called LDA. So LDA is a machine learning algorithm. It is a supervised machine learning algorithm which is used for classification. Okay, so before we proceed, I will implore you to subscribe to this YouTube channel to get subsequent updates, subsequent videos and content relating to machine learning and data science and also web development. You can also follow us on Facebook using the link below. Okay, let's proceed. So we'll be discussing the linear discriminant analysis LDA, which is a supervised machine learning algorithm for solving classification problem. How do we train an LDA? LDA is a combination of features, which is trained by combining different features and with the classes. So this particular definition I give here says linear discriminant analysis is a supervised machine learning for solving classification problem. LDA is trained by finding a linear combination of features that separates two or more classes of objects. So looking at this particular definition, I'm actually trying to define in such a way that we have combination of features, but each for each classes. So let's proceed to the training process. In the training process of LDA, so we try to estimate constant and weight for each class in the data set. So let's say we have a particular data set with 4 features, X1, S2, S3, and X4, and 3 classes. So what we do in LDA is we produce constant and weight for each of these classes, each of the 3 classes. So the first class, we have a constant and set of linear combination of weight, which is also called linear coefficient, W1, W2, W3, W4 for that particular class. So class 1, class ID1, we have a constant, a single value, and weight, which are 4 weights. Then we also have class ID2, which we also have a constant and a set of values. So we have this particular predator for each class. So we make a predator for each class, which looks like this. Okay, so this is the training process of LDA. Then the question in LDA is like, how do we estimate this C1 and how do we estimate the weight? How do we estimate the constant and the weight? So that's what we do in the training process. These are the formulas for the weight and the constant. So to define the weight, we have to find also the mean, which is MI, the mean of subset data for that particular class. Okay, let's say that we have a class ID1. So we get subset data, which are data inputs for the class ID1. Then the subset data, which for the class ID1, we find the mean. Considering the training example we've given here, which has 4 features, X1, S2, S3, and S4. Then we have 3 classes. Now we can then extract for class 1 the feature set, the data input X1, S2, S3, X4. So let's say that we have a particular data set. Okay, for this tutorial, we'll be using the iris data set. In the iris data set, we have 3 classes of flowers. And the 3 classes of flowers, which is 3 classes, and we have 4 features also for the iris data set. The training records in iris data set is 150, which means that we have 50 records for each class. Then what we do, the way we get this MI, which is the mean, we extract subset class for the first class, which is that 50 record. So let's say that for a class ID1, the first class ID, we extract the subset class for it. Then we find the mean of every features, which is this MI. So mi is a set of values for each features, which is the mean. So in case of this, in which we have four uh, four features, then which means that mi will be a matrix or a vector of 1 by 4 vector, which means that 1 by 4 means that we have four. For this x1, we have a mean value. For x2, we have a mean value. We have x3, we have a mean value, and x4, we have a mean value. So for the training class ID1, we have four values for the mean, which define the mean of these features. And take note that this mi is for that particular class. So we also do the same thing for the second class. We do the same thing for the third class. Then we find this covariance information. I call this a covariance information. This is how we find it. This is a summation for all the three classes. So we find the numbers of record for a particular class. For example, in the first class, we have 50 record. So it will be 50 minus 1 over n. N is total numbers of record, which is 150 minus NC, 3 classes. NC is the numbers of classes in the data set, which is 3. I'm describing this 3, 150. This is for Iris data set. So if we have some other data set, it should be specific to that particular data set. So in my data set, which is I define as the Iris data set, 150 records, 50 for each classes. Then if I'm going to find the covariance information, I have to look through the 3 classes. For each classes, I get Li, which is 50 for that particular class, minus 1 over the total numbers of class, which is 10, total number of records in the class, 150, minus NC, which is 3. Then I look for the covariance matrix, this covariance matrix for Xi. So covariance matrix is like the subset data I've extracted for that particular class. So I'll extract for a particular class, then I'll get the covariance matrix. So I'll multiply this for a particular class, then I keep on summing it up for all the 4 classes. Then I have this covariance information. Then from there, I can find the weight for this particular class, for a particular class. So do that for different classes. Okay. Then in the constant estimation, how do we estimate the constant? We estimate the constant using this formula. We find the transpose of the mean that we'll find here. Then we multiply it. Then we have this pi. This is another variable, a new variable. So pi is simply the probability. The probability. Then it's just the probability, like the ratio of the numbers of class and total numbers of record in the data set. Is the ratio of the numbers of record in the particular class over the total number of record in the data set. For the first class, which we have 50 record, it will be 50 over 150. So also for the second class, so that is for Iris data set. Then in this classification process, process, what to do in classification process, like what we have gotten, the W and the C, we want to use it for predictions, for classifications. So you can recall that in our equation for here. So this is the equation. So that's the same equation we're using for the classification process. Now we've obtained this W, we've obtained C for a particular class, for all the classes in the data set. So what we do is, like, we just use the estimator for the first class. Let's say we want to classify a set of inputs for a set of inputs 0.5, 0.6, 0.8, 0.9. So this is my x1, x2, x3, x4. So from the training process, we've already obtained a set of weights for each classes, and so also constant for each classes. So we then use this weight. We multiply this weight, W1 multiplied by X1, W2 multiplied by S2, W3 multiplied by S3, W4 multiplied by S4. Then we add the constant value. So this is for a particular class. So we do that for the 3 classes we have in our data set. So the one that has the maximum value The class that gives the maximum value is the predicted class. So the predicted class is given by the class ID that gives the maximum value of y. So that's the training process and the classification process of LDA, linear discriminant analysis. So now let's move to Matlab to see the code implementation. So these are Matlab code. You can see my Matlab code. I'm using the iris dataset, which is from Matlab. So this iris dataset, I try to process it just to make sure that everything looks good. So I have a set of value x and y here, x and y. X is a record of 150 by 4 matrix. Then we have y, which is also a record of 150 by 1. So we have, just like we have given in this particular algorithm, we have a training record of 150 records. Then I use cross validation process to split my data set into training and testing. So I try to split the data set into training and testing here. So we have the training input, the training target, which is a white train, and also testing input and testing target. So that's what I did here. So this is where the process should start from, which is process of estimating everything. So here we have I computed the size of the training record. Then I also find the numbers of class. Definitely there are 3 classes. So, but it's still also good to find the numbers of class. So these unique values, I must get the unique values of y. Let me try to run this code. So try to run this code so you can see everything on my workspace. So this is my workspace. You can see that the numbers of classes is 3. So let's start from the beginning. The training record x is 150 by 4. Then we have y to be 150 by 1. Then we've divided into training and testing. We've created a training size of 120 by 4 and the testing size now 30 by 4. Likewise, our y train is also 120 by 1 and 30 by 1. So starting from here, which is where we get everything right. So we first get the training dimension, m and n is definitely the total numbers of record in the training set, which is 120. So you can see that n is 120 and m is 4 features set, 4 attributes in our data set. So what we do is like we initialize a particular matrix to store the mean of the subset data for each class. So we also initialize this particular matrix prob to store the probability. Then we also start by getting covariance information. Our covariance information should have been a 4 by 4 matrix for the 4 features. So then we create an initialization because it's going to be summed up to this 0 matrix. So that's where we started from, this 0 matrix. So let's start by, then we look through the training classes, which is numbers of classes 3. Then for each class, we extract subset data. See, subset data that correspond to this particular class ID. Thus, from subset data, we extract the input set. So this input set also we find total number of record in that set. So we find the number of record for this set, then we get the probability. Probability is just the total number of items in a particular class ID divided by the total number of record in the data set. So our n here is now 120. Then this one is the total number of record in that particular data set. So you can see that the last value of n was compared to 42. So this is 42 divided by 120. So this is going to give us the prob for this particular class. So starting from 1, we get this to up to the third one, which is n class. Then after estimating this, we find the mean. So this particular mean here. So we find the mean here. So mean mi. So that is what we find there. So mi is estimated for each class. So we find it for input, that is for this particular class we are looking to. So mean of this. Then we store the mean. we store it for future use. So after storing the mean, we also calculate the covariance matrix. So this covariance matrix is used to estimate the covariance, update the covariance information. So you could see you used to update the covariance information. So this is same thing as this particular formula. Li minus 1, total number of record in the for the class ID over total number of record in whole training set minus n class, which is 3 times the covariance matrix. So this is it. So we have also the weight, the weight of this particular data set. So we estimate the weight. So this particular weight now, in this particular stage, you want to find the weight. So this weight parameter, we also call it beta anyway, and it's also called our linear coefficient. So we want to find the weight and the constant for each class. Then you should know that we are going to use this mean and this covariance information. You could see that's the two parameter being used, mean and the covariance information, mean and covariance information, and also the probability. So you could see here. Then what we do then here, we just look through the linear, the numbers of items in the training, the numbers of classes. So for each class, we find the weight using that particular formula I showed you. So this formula we use to find the weights, which are the constant and the linear coefficient. So this is the constant formula 0.5 mean over covariance information multiplied by mean, the transpose of mean plus the log of the posterior probability of that particular class IDC. So we also do the same thing for the weight, use the weight formula. So that's all about the training process. Then in the training process, we get weights. You can see our weight is now 3 by 5 matrix. So 3 by 5 matrix. It is 3 by 5 because we actually have added the constant values, the constants. So normally it should have been 3 by 4. Then we have a constant which is also 3 by 1. So let's look at it. If you click on this, or let me just write it here. Weight. So you could see that, so this particular three values is for the constant. So it's the first thing we estimated here. So for the three class, we have this, and this. So these are the three classes. So this is the constant for the first class. This is the constant for the second class. So this is the constant C for the third class ID. So these are the coefficient, linear coefficient for the first class, linear coefficient for second class, linear coefficient for the third class. Then in the classification process, what to then do in classification process is to look through the size of the data set. So we look through the size of the testing set. We want to now test. So this should be testing set. So we look through the size of the testing set for each test samples. We extract test samples. Then we use this formula, this last formula that I described here, the classification process, the constant for each class. We multiply it by, we add it with the linear coefficient, multiplying the linear coefficient with the input set. So which is this test sample? Our test sample here was this. I use this as an example of the test sample. So we multiply by this weight. You multiply by weight. So after multiplying by weight, then we add it with the constant. So what exactly, how do you make the prediction? The one that gives the maximum value, the training class that give the class ID that give the maximum value of the predictor, which is Y, is our class. So I did a confusion matrix to estimate the accuracy. So you can see that we have a very good accuracy, which is 96.67. If I run again, I might even get something much more better. So you can see, so this is how we perform linear discriminant analysis. So you can see we get more better accuracy, which is 100. So machine learning is very interesting. I hope you subscribe to this YouTube channel so you can get wonderful content like this. Thank you so much for for watching this tutorial session. Thank you. I'll also put the um, code link, this particular code, the GitHub link to the comment section in this particular description of the video. So you could see the GitHub link of this particular code. There you If you want to apply it to your own data set with just by easily changing little modifications, you can apply it to your own data set. Then you can also see now Matlab documentation on how to perform linear discriminant analysis. That is, there are inbuilt code for linear discriminant analysis in Matlab. But for this particular tutorial session, we demonstrated the algorithm. Then we also try to write our code from scratch, which is good to understand what is going on in the algorithm. So thank you so much for watching. Thank you. Yeah. Bye.